Alright, so hello guys, my name is Fatin. I'm from Brack University and today is my first session with linear algebra. Now, to understand linear algebra, you need to understand linear systems and then raw echelon form of matrix, or you call it echelon, right? Alright, so what is linear systems? So linear systems means this I have written. Notice that there is power only one, nothing else. No, um, it cannot be x square or x cube or x to the power 4, or it cannot be even below 1, like minus 1, x to the power minus 2, or even 0. It exactly has to be 1 power. I mean the power of the variables must be 1 in order to become a linear systems. If it is other than 1, then it's not really a linear systems. That's another topic of study. So alright, so now this is the linear systems part. Now we will proceed to the next part. Alright, so if you are told that there is a linear system, linear systems kind of arrange like this. This is just an example, so should be fine. Into 6, right? And then 2x plus 5y plus 9z equals to 8. 3x plus, alright, 6y plus 10z equals to 10. Alright, so if we want to write it in augmented matrix, what we have to do is we have to write like this. I mean, we have to write the coefficients. Notice that x's coefficient is 1. If it's empty, then it's 1. So we write the coefficients 1, then y's coefficient 3, and z's coefficient 7. There we go. Now you have to write these two. That's why that's what it is, an augmented matrix. Just be sure to write it separately. Alright, never mind. Seem to have messed up a little bit. Alright, so this is 6, right? Then 2 into 2, 5, 9, and 8. And then similarly 3, 6, 10, and 10. Yeah, that's much pretty much works like this. Now this is just an example of augmented matrix. So row echelon form, I mean, we use it on matrix mostly. You can see that. Now see here, it's the same thing. You can pause the video. I will upload it certainly and see. Alright, so alright, let's try to solve it. What we have is what we have is if there's nothing like but there is actually x, you mean it's never mind. Still, now what I was talking about, that there was actually x, but it's like this, 0. If there's no x, then assume that the coefficient is 0. 0 into x equals to 0, right? So they didn't wrote it. So what will be this? 0, then 10 minus 4. Now we have another variable which is w. So w's coefficient is 1 and the the right side is 1, so we write it there separately so we can understand, so we don't mix with it. Then 1 4 minus 1 into 1 into 2, then 3 2 1 2 5, then minus 2 never mind, I have to go down a bit below. Alright, so minus 2 minus 2 minus 8, this is 8 no, never mind, my handwriting is very bad, so if you don't understand anything, just ask. You can also ask anywhere you can find me. Alright, minus 4, and there's no space actually, but yeah, you can imagine this will be 1 minus 6 3, and since it's empty, so it will be 0w, which means it will be 0. If there's, I'm saying it again, if there's nothing here, your equations has 4 variables, right? But in any equations you see that there are only 2 or 3 variables. You have to assume that the missing variables coefficient is 1. For example, see here you have 4 variables x, right? But here is x is not present. So what does that mean? It means that it's 0. That's it. It's easy. Alright, so oh, I love this one. This one's actually easy. I mean, you can do it actually. Just now I have to tell you that when you are declaring a variable or actually assuming something, you don't necessarily have to do it x, y, z. You can write it as x1, x2, or x3, or x4. I mean, however you want. I mean, it x, y, z, x, y, z, w. These are ideal for like 5 to 6 or 4 to 5 variables. But what you have a larger matrix, then what you would do? You have to write it like x1, x2, x3, or x4. Yeah, that's it. Alright, so if you need help with this one, just ask me. Alright, I won't mind, or you can tell me in the comment sections. I can I can provide a small video how you do it in full explanation. Alright, this is my favorite part. Now the idea of Gaussian elimination method. So Gauss actually proposed that swapping two equations 0 doesn't change the system. Alright, what does that mean? So it means that like you have x plus 3y plus 7 set into 6, right? And then you have 3x plus 6y plus 8 set into 7. Yeah, so now if you swap, like you swap this equation to there and take this equation here, you're swapping places, right? So if you swap place, it won't really change the system, or to say it in mathematics, it won't really change any kind of solutions or anything. I mean, it's pretty much simple, right? For example, you and your friend both are sitting together now. If I replace both of you, I mean, if I swap places between you, it's really same, right? Nothing happened. It's very normal. So yeah, that's it. Alright, so another thing, multiplying an equation by a non-zero constant doesn't change the system. It's pretty simple too. Let's see, x plus 3y plus 5 set 6, and there is, alright, we don't really need to one. Alright, now for example, I mean, you actually know it. Now if I multiply the both sides by 2, it won't really change, right? That's what Gauss has said. It's a common sense actually. I mean, if you did mathematics in elementary school, it's actually easy, because I am adding the both non-zero constant. I'm adding non-zero constants in both sides, right? So I mean, the both sides, so nothing is really changing because I'm really adding in both sides. It's like an equilibrium. I am putting the same weights in both sides, so the equilibrium stays equal. I mean, forgive me, my English is not that good, but I'm trying. That's it. So alright, so that's it for today, and it's a very big topic actually, so I have to take another session for it. Now let me know if you want more sessions from me. If you do, I would be happy to oblige to you, and that's it for now. See ya guys.